Hi there, welcome back to Working with X as a Number, and this is part 2 where we're going to check out those little problems I left you to simplify expressions with X. And then if you look at the title up here, we're actually going to go on with working with equations with fractions in them and seeing if we can unpack our present and solve those equations even though they have fractions. So let's have a look at X as a number. So 2x plus 3x, 2 lots of a number plus 3 lots of the same number would be 5 lots, like adding up 2 dogs plus 3 dogs. Let's do the next two together perhaps. Neg 4x plus 7x. Oh, do you need a number line for this one? Neg 4x is down here, and then, so this is 0 here, and then plus 7x, 2, 3, 4, 5, 6, 7 would end us up at 3x. Down neg 4x, and then add 7x would come up to 3x. So let's put that there then. We've done those next two, and then we have a take 5x on the end. So adding these up, 5x, well we could say 5x take 5x, there's no x's, and you're still left with the 3x there. There's a few different ways of combining these together, but that's one way of it, of doing it. Okay, let's look at the next one. Let's try and do them all together. 4x take 7x is neg 3x, plus 5x is plus 2x, take 10x is neg 8x, plus 3x is neg 5x. Now, I've done that all in a row. You might like to go back and do some of them, working them out on the number line there to make sure you understand the positives and negatives. Let's have a look at the next one now. There's 2x plus x is 3x. Oh, no, this is different. That's just a number. There's no x's there. Better leave that one. We've got 3x plus this x is 4x. Take 3x is 1x. Now let's go back and look at the numbers, because we can collect up the x's. They're all lots of the same missing number. X is standing for the missing number. But these two numbers, neg 5 plus 7, would be positive 2. So we generally write this as x plus 2, leaving the 1 out in front of the x. Can you see? A bit different there. And what this is called is collecting like terms. Collecting up terms, expressions that are like each other. Collecting like terms. So it's x's together and numbers together. Alright, so let's have a look down here now. Oh, it's starting with a number, so start there. 4, there's another number, plus 2 is 6. Take 9 is neg 3. Now let's do the x's. Neg 3x plus 5x is positive 2x. Take 4x is neg 2x. Okay, so are you getting the hang of it, do you think? It's collecting up like terms. Right, let's have a look here. In this problem, the timesing sign is a bit confusing. We have 3x times 2, or 2 lots of 3x, that would be 6x. Now we've got a timesing here, 2x times x. Oh, a number times itself is the square. So that will be plus 2x squared. Let's join these together here. 5x take 2x is plus 3x. And then we've got another neg 5x squared on the end. So collecting them up again, we've got 6x and 3x is 9x. And 2x squared take 5x squared is negative 3x squared. Getting the hang of it a bit now. Let's go down and have a look at the last one here that I like this one. And so here we have 5x squared. Take 2x squared is 3x squared. Plus 4x squared is 7x squared. Picking out all those terms, they're the same as each other. Let's pick out the x's now. It's 3x plus 2x is 5x. Then we've got neg 2 and the other number here, plus 3, would be positive 1. So that's quite a big one. Quite a big one there. We've got 3 different terms, the types of terms there. We've got the x squareds, the x terms, and the numbers. So we've got to collect them up if they are like each other. Now, these last 3 were a bit different, and this was really revising what your work with fractions was about. So in Xland, of course. So we want a common denominator here of 10, so we multiply the first one by 2 over 2, plus the second one we'll multiply by 5 over 5. And let's see, has that worked? Yes, that's given us a denominator of 10 there, and 2 by x is 2x, plus denominator of 10 here, and x by 5 is 5x. Remember, we put the number in front of x usually. So now we have 2x tenths and 5x tenths. So overall we've got 2x plus 5x is 7x tenths. So we can combine them together. Remember our work with fractions now. You can combine them together because they have the same denominator. They're dividing things up in the same number of parts, tenths. Let's have a look at the next one. Common denominator would be 15. So let's change the denominator of the first fraction to 15 by multiplying top and bottom by 5. And then we'll take away, let's change the denominator of the second fraction by multiplying top and bottom by 3. So there we have 15 for that denominator, and 5 times x, 5x over 15. Take, now x times 3, we'll always put the number in front, is 3x over 15, so it's working for us. We have got the common denominator, and we've got 5x fifteenths. Take 3x fifteenths, that would be 2x fifteenths that we'd have left. Alright, so are you getting the hang of it? Just remember, x is just another number. We don't know what it is, but it is just a number. So let's have a look at this last one now. 2 over 7x plus 4 over 2x. Well, they've both got an x already, so it's only a matter of making the number in the front the same or in common. So let's multiply the first fraction by 2 over 2, and that would give us 14x in the bottom line. And the second fraction, if we multiply by 7 over 7, that'll give us 14x in both cases. So let's go for that. We've got 14x here, 2 by 7, and 2 by 2 is 4, plus here 14x, and 4 by 7 is 28. So can you see that if x is in the bottom line or in the denominator, you can still do the same sort of stuff, because x is just a number. So here we have 4 over 14x plus 28 over 14x. They're the same units now, so we can have 32 over 14x. Do not get fazed by x there. It's just another number. Now, where do you think all of this is leading? Do you remember where we started way back? It was with solving puzzles. So what about having a look at perhaps a different type of puzzle? Oh, what are these here? Well, could we say, how would this equation down here have come about? Well, I don't know. What? Think of a number? I don't know. We go back to that. Think of a number, the puzzle. Divide by 6. And the answer is 5/8. And we've made a little mathematical sentence or equation here, which says just that, doesn't it? If the number is x, we have divided it by 6, and the answer is 5 over 8. Now it's written from left to right, written backwards. We're actually saying 5 over 8 equals x over 6. Can we solve it? Now, let's do some together. I think, let's call these mine. And over here, these are yours. Okay, so I'm going to do one. I'm going to ask you to do one. Right, let's have a look at this first one here. Oh, there are fractions in our mathematical sentence or equation, so let's get a common denominator. So we're having a look at 8 and 6. What's the smallest number they'll both go into? Can you see it? It's 24. So let's multiply top and bottom by 3 here to make a 24 in the denominator. And if I multiply top and bottom here by 4, that will make a 24 in that bottom denominator. So let's have a look now. That would be 3 by 5 is 15 over 24 equals 24, x times 4. Always put the number in front of x, 4x over 24. So the denominators here check out as being the same. So to keep these two fractions equal, what do you reckon? The numerators or top lines must be the same. So that's all we need to do there. Now, do you remember x has been times by 4? So we'll unpack our present, we'll divide by 4 and come up with that answer. And of course, you might like to change that to a mixed number, as mathematically this sort of fraction is deemed to be in simplest form when it's a mixed number. So 4 into 15 goes 3 4s are 12 and 3 over 3 3/4. Okay, so problem solved. Let's have a look at yours. So you might like to pause the presentation now and have a go at your first one. Here's your first one over here, and see what you think. All right, coming back, what are we going to do? Well, 2 7s are 14. That's probably the easiest way of looking at getting a common denominator. So we're going to multiply top and bottom of this side by 7, and this side top and bottom by 2, using the opposite denominators if you like. This then will produce 14, and this will produce 14. And in the top line over here, 7 times x is 7x over 14 equals here 4 by 2 is 8 over 14. So the bottom lines check out as equal. So for the two fractions that we started with to be equal, the top lines or the numerators must be equal. So 7x must equal 8. What's been done to x to get 8? It's been multiplied by 7. To get x back again, we'll divide by 7. And again, you could call this a mixed number. 7s into 8 goes once and 1 over, so you could call it mixed number 1 and 1/7. Did you enjoy that? Did you get it right? Do you need to perhaps pause the presentation and check out what's going on there? We're going to build these up a little bit. So coming down here to these, what's the difference? Well, in the top line, we've got both sides, both fractions on either side of our mathematical sentence have got x's in them. Now, you can stop me at any time, and you might like to do more and try mine before I do them. All you've got to do is pause and I'll stop. Okay, well I'm going to go on now, and let's have a look at 3 times 2 is 6. So I'm going to multiply top and bottom by 2 here to create my 6. And over here to create my 6 in the bottom line, I'm going to multiply by 3, the denominator from the other side. Let's do that now. And this denominator is 6. 2 by 2x is 4x equals, oh, funny business happening here. Denominator checks out okay, but we need to multiply all of this one. Haven't seen one of these before. All of this one by 3. So I think we should put a bracket there to remind ourselves the top line consists of that whole bracket. It's all got to be times by 3. So let's do it. 3 by 5 is 15. Take 3 by x is 3x. A little bit of a tricky do there. Okay, because again, 5 take x is just a number, but we don't know what x is, so we have to multiply both parts of that number, the 5 and the x, by 3. The denominators here are equal, therefore to keep the fractions equal, 4x actually has to equal 15 take 3x. Now this takes us back a bit. We have x's on both sides. Now we need to collect them up. If we were to add 3x to both sides, how did I work that out? Well, let's have a look over here. If I added 3x, this is take 3x. If I added 3x to that side, I will actually wipe it out. I'll remove it from that side. To keep the equations equal, obviously, or to keep the sides equal in this equation, then we would have to add 3x to the other side. But just watch that step now. We looked here and we saw a neg 3x. We want to get all our x's together on the one side. So we will add 3x, do the opposite there, so it disappears. And over on this side, the same thing. So our total x's on this side will be 7x, and it's just 15 left over here. What's been done to x? It's been times by 7. So to get x back again, we'll divide by 7. And what's the meaning of that fraction? 7's into 15 goes twice, 2 7s are 14, and 1 over. So it's the same as 2 and a 7th. All right, it's over to your next one. And you've got the same situation with a bigger expression in the top line of your fractions on either side. So you might like to pause me now and have a go. Oh, here we go. What is the common denominator? 3 times 4 is 12. So let's change this side's denominator to 12 by multiplying by 4 over 4. And on this side we'll multiply by 3 over 3. So we will be creating the 12 on both sides. Let's do that now. So in the bottom line it's 12. Oh, the top line, 4 times all of this using a bracket. So it's 4 times x will be 4x plus this plus in here, and we must multiply the 1 by 4. The whole top line has to be multiplied by 4. It doesn't look like just a number, but it is. X plus 1 is just 1 more than x. X is a number, so x plus 1 is a number, and we have to multiply that number by 4. Over on this side, we've got 12 in the bottom line, that checks out. Now it's 3 times the top line, or let's use a bracket to remind ourselves that it's 3 lots of the 2x, which is 6x. Take 3 lots of the 1 in here, which would be 3. Now the denominators or the bottom lines are the same, therefore we can say the numerators or top lines must be the same if these two sides are going to be equal. There we have it. We've got the same challenge though. We need all the x's together. So let's say, well, most people like to work with the x's on the left. So let's try and remove this 6x. Can you think of any ways of doing it? Well, it's positive 6x. So let's take 6x from both sides. So it would be on this side, 4x plus 4, take 6x. And over on the other side, 6x take 3, take 6x. Yes, it's worked. Wipe out. The x's are wiped out there, and you've got 4x take 6x is neg 2x plus 4 equals, over on this side, what's left? Neg 3. So do you remember? X has been multiplied by neg 2, and 4 has been added. So we're going to unpack our present, and let's subtract 4. So neg 2x plus 4, we can put in full if you like, take 4, so that will wipe out, equals neg 3, take 4. Do the same to both sides. So now we have neg 2x equals neg 7. Therefore, dividing by neg 2, x is neg 7 over neg 2, or x is 7 over 2. And you might like to call that again 2's into 7, 3 2's are 6, and 1 over, so it's 3 and a half. That was quite a big dude, that one. A fair bit to do there. So remember, you can pause the presentation any time and just go back and check it out. Let's go down again. We've only got a few more to go. Do you want to pause me now and have a go at my next one over here? Here we go. Common denominator would be 10, so we multiply this side by 2 over 2 to get a 10 in the bottom line, this side by 5 over 5 to get a 10 in the bottom line. Just check it. Yep, 2 by 5 would be 10, 2 by 5 there would be 10. So we are happy with that. The bottom line is 10. Let's have a look here. 2 times the top line, we better use a bracket. So it's 2 times 3x is 6x, plus 2 times 2 is 4. And then on this side, our bottom line, our denominator is 10, and we need to multiply across here. So using a bracket, 5 lots of 2x is 10x, take 5 lots of 1 is 5. Denominators check out as being equal, therefore to keep the fraction on the left equal to the fraction on the right, the numerators or top lines must be equal. You want to keep the same method up of collecting all the x's across to the left. If you do, we need to move this. It's positive 10x, so let's take 10x from both sides. So 6x plus 4, take 10x, would equal 10x, take 5, take 10x, and we get wipe out. 10x take 10x is 0x, and that's why we've done it. So we're collecting all the x terms on the left. 6x take 10x is neg 4x, plus 4 equals, what's left here? Negative 5. What's been done to x? It's been times by neg 4. You can write it down over here to help you. And then 4's been added. So we're going to unpack our present, if you like, reverse the steps. Let's subtract 4. What does that look like? We wrote it out in full. It would look like this. And that would remove the 4 from that side, unpacking our present. And we'd have neg 4x equals neg 9. Then if we divided both sides by neg 4, do you want to do it in full here now? Then that would cancel, and we would have x is neg 9 over neg 4. Negative divided by a negative is a positive, so we just call it 9 over 4. And again, as a mixed number, 4's into 9, 2 4's are 8, and 1 over. That would be 2 1/4. Okay, if you're up to this, you're doing very well. This is towards the end now of working with fractions in Year 10 Maths, so in algebra. So let's have a look now at yours over here. Have a look at those two denominators. Might be a bit easier this time to get a common denominator. So do you want to pause me now and have a go? Right, let's look at the denominators. A bit different here because I only really have to multiply this side to get a 6, don't I? You can make it into a 6. The 6 is already over on the other side. So the common denominator is actually one of the denominators itself. So it's quite handy to spot that, because now if I multiply top and bottom by 2 here, then I would produce a 6, and I don't have to do anything to the other side. So let's do that now. Multiplying top and bottom by 2, that's 6, and then multiplying across here using a bracket. 2 by 2x is 4x. Take 2 by neg 1 is neg 2, which is equal to 4 take x on 6. So this was a slightly easier one now. The denominators are the same. We only had to change one of them to make them the same. So now if the fractions are going to be equal, the numerators or top lines must be equal. We're putting them equal now. Now moving all terms to the left, you don't have to, you could move them to the right. We're doing this the same method every time here so you can follow it. This is neg x. If I need to move it, need to remove it from that side, I'm going to add x to both sides. Let's see how that works. We've got 4x take 2, add x equals 4 take x plus x, wiped it out. And so over on this side we have 4x plus x is 5x, take 2 equals 4. What's been done to x? It's been times by 5, and 2's been taken away. Unpack your present. Add 2 to both sides. Let's see it in full then. Add 2 to both sides. There we have it. And that will wipe out. So we've got 5x equals 6. Dividing them by 2, dividing by 5, sorry. Reversing that step, doing it in full now. We will say we'll get x back again. X is 6 over 5. And 5's into 6 go once. And 1 over. So that's 1 1/5. All right. Well, if you're still with me there, you can be very proud of what you're doing, because this is reasonably challenging. Let's have a look. I think we've just got 2 down here. We'll just bring them up. And then we're finished. Oh no, hang on. We've got some more coming on below. How many more have we got? Let's have a look down here. Oh yeah, we've got some little ones. Okay. Some little ones there still to do. Of course, if you're getting a bit tired, you can pause the presentation, come back, or close it down and come back on a different day. Let's keep going. Do you want to have a go at my next one? There's this one over here. If you do, pause the presentation and beat me to it. Here we have a common denominator of 14. So to make that, we'll multiply top and bottom of this side by 2 and top and bottom of this side by 7. Let's have a look now. That produces 2 7s are 14. And in the top line, it's 2 by all of this, which is 8x plus 14. That's 2 by this 4x and 2 by the 7. And over on the other side now, 2 7s are 14. Yep. And in the top line, it's 7 times all of this. So 7 times 5 is 35. Take 7 times x is 7x. The bottom lines check out as the same. Therefore, the numerators or the top lines must be the same. And so we'll put them equal. Now we want to collect all the x terms on the left-hand side here. This is neg 7x. So let's add 7x to both sides. We'll have 8x plus 14 plus 7x. And this will be equal to 35, take 7x plus 7x. Wipe out. Over on this side, 8x plus 7x. 15x plus 14 equals 35. What's been done to x? It's been times by 15 and 14's been added. So let's reverse those steps. Let's subtract 14. So 15x, that 14 will disappear. 35 take 14 is 21. Now dividing by 15. Just jumping a couple of steps there in the way we're setting it out, is 21 over 15. Oh, can you see what we can do? 3's into 21 is 7. 3's into 15 goes 5. So the simplest fractional form is 7 over 5, or the mixed number. 5's into 7 goes once, and 2 over. So it's 1 2/5. So that was a good one. Getting quite big. I think this one over on your side now is the last of our biggies, and then we've got a few rather simpler looking fractions down below here. You want to just take a peek, see some of these here. A little bit easier in a way. The only difference is the x is in the bottom line. So we'll come and have a look at that in a minute. So do you want to pause the presentation and turn me off for a minute and have a go? Just have a look at those 2 bottom lines there. Do we have to change both of them? All right, have a go. Coming back, can you see that we can get a 6 out of this negative 2 by simply multiplying by negative 3 over negative 3. That's a good shortcut for our common denominator, because negative 2 by negative 3 is positive 6. So let's see what that looks like now, if you spotted that. So this is now positive 6, only having to change that one denominator, that one bottom line. Now I've got to be careful here, let's use a bracket. Neg 3 times 4x. Negative times a positive is a negative, neg 12x. Then neg 3 by neg 1 is plus 3. Okay, so the bottom lines check out. Yep, they're the same. So the top lines must be the same. And we can write that. Collecting the x's up, this is neg 12x, so if we add 12x to both sides, we'll have 15x here, plus 1. Adding 12x to this, we'll wipe it out, we'll produce 0 x's, and leave a 3. X then has been times by 15, and 1's been added, so let's subtract the 1 from both sides, we'd have 2. And then dividing by 15, we'd have 2/15 as our answer. All right, well, how did you go? That's the hardest one of that type. All right, so let's move down and have a look at the next little ones here, because they are ones where the x is in the bottom line. Okay, and they're the first equations or mathematical sentences that we have seen with x's in the bottom line. So, mine and yours again, you better watch me for this one, and then see if you can follow what's happening. What do we want? We want a common denominator. So the common denominator would be 3x. So we need to multiply this top and bottom by 3, and over on this side, this top and bottom by x, because that then would produce 3x there and 3x there. So let's do that. We've got 3x. So now it's top lines together, 15. And over here, that's bottom line is 3x. And the top line is 2 by x is 2x. So the bottom lines check as being equal. Therefore, the top lines, or the numerators, must be equal. So 15 equals 2x. X has been times by 2 to get 15. We'll now divide by 2 to get 15. So there we have our answer, and again, as a mixed number, it's 7.5. All right, do you want to pause me now and have a go at your first one of this type and see what you think? Okay, coming back, common denominator is 5x, so I need to multiply top and bottom of this side by 5 and of this side by x. So let's look at that now. This gives me, yes, 5x as a denominator. The top line gives me 5 by 6 is 30. Equals, this is 5x in the bottom line here. And here, this is 3x. So the bottom lines are equal. So the top lines must be equal. And dividing both sides by 3, x has been times by 3 to get 30. Getting x back again, 30 divided by 3 is 10. Our problem solved. So it's the same idea, just remember, working with x is like working with any other number. Make sure you don't pick on the little dude, he's just another number. Okay, let's go on now. So remember, do you want to have a go at mine first? So just pause me. Otherwise, here we go. Common denominator would be 3x. So you have to multiply top and bottom by x here. And over on this side, top and bottom by 3. Let's see it now. That's going to give me a 3x. That's going to give me a 3x. So that's going to work well for us. So x times 4, always put the number in front, is 4x. Equals, x times 3 is 3x in the bottom line. And 5 by 3 is 15. Bottom lines are equal. Top lines must be equal. To have the two fractions equal, numerators must be equal. So we've got 4x equals 15. X has been times by 4. To get x back again, we'll divide by 4. And there's our answer. As a mixed number, 4s into 15 goes 3 times, and 3 over. So it's 3 3/4. All right. Have a go. Here's your next one here. Now, do you want to pause the presentation? Have a go. Just have a look at those bottom lines. Okay, here we are back again. There's something already common with our bottom lines here. 2x and 6x. So let's see, 2x and 6, sorry. So let's see if we can make the 2 into a 6. Well, we can do that by multiplying top and bottom by 3. That would give us 6x. And if we did the same manoeuvre here with x's, multiplying top and bottom by x, can you spot that we've done this quite neatly? We've got 3 times 2x on the left denominator and 6 times x on the right. So in other words, they are both quite easily changed into denominators of 6x. So 3 by 3 on this side is 9 equals, over here 6 by x was 6x, and in the top line 7 by x is 7x. So the denominators are now the same, so the numerators must be the same. Keep the two sides equal. X has been times by 7. To get x back again, we'll divide by 7. So our answer is 9 over 7, or again as a mixed number, 7 into 9s go once, and 2 over, so it's 2 7s. Okay, well here we are, almost at the bottom here, so let's just go down a bit and have a look at our last 2. So do you want to pause and have a look at my next one before I do it? Please yourself, here I go. So here we have, I think, a common denominator of 6x. So let's multiply top and bottom by 3. And over on this side, we'll multiply top and bottom by, 2x. And so our denominator here will be 3 by 2x is 6x. And 3 by 3 is 9. And that would equal over here 3 by 2x, yes, 6x, that's working for us. And 7 by 2x is 14x. Denominators are equal, therefore the numerators must be equal. Okay, what's been done to x? Been times by 14. To get x back again, we will divide by 14. So we have solved our problem. All right, have a look at your next one, the last one in this presentation. So are you going well? How do you feel? Do you have favourites? Do you have ones that are bothering you? You might have to go back and have another go. Well, we'll look at these denominators. So I want you to pause the presentation now and have a go, but do it the easiest way for that common denominator. All right, coming back, could you see what I meant? There's a 3 and a 6. So can we make that 3 into a 6 by multiplying top and bottom by 2? And then over on the other side, multiplying top and bottom by, this is neg 1 over 6, multiplying top and bottom by x. So we can find an easy way to get the common denominator of 6x on both sides. 6x. And on the top line here, it's 2 by 7 is 14 equals 6x here, that works for us, common denominator. Neg 1 by x is neg x. Denominators check out, so the numerators must be the same. 14 equals neg x, multiplying both sides by negative 1 would make this a plus x. So x would be neg 14. So that's a lot of work. Hope you did well with that. Let's see what this one looks like over here if we don't spot this common denominator. We'll just come down here a bit. I've gone too far now. So let's use this equation. If you didn't spot the easy way of getting the common denominator, what might you do? 7 over 3x equals neg 1 over 6. Well, you could call the common denominator 18x. It just makes the numbers bigger, which you would multiply both sides by 6, top and bottom by 6 here, and over on the other side, top and bottom by 3x. This makes it a little bit bigger to work with. 6 by 3x is 18x, and here 6 by 7 is 42, equals 6 by 3x is 18x, and neg 1 by 3x is neg 3x. So if we come down a bit, the bottom lines are still the same, and here we have the numerators or the top lines, 42 equals neg 3x. X has been times by neg 13. To get x back again, we'll divide by neg 13. And a positive divided by a negative is a negative. So, not neg 13, sorry. We want here just neg 3, don't we? I just scrub him out there. So x has been times by 3. We'll divide, times by neg 3. We'll divide by neg 3. Positive divided by a negative is a negative. So that's neg 14. So it's the same answer, isn't it? Doing it this way here. If you don't spot the slightly quicker way from what we did up here, okay, you end up with slightly bigger numbers that you have to divide out at the end. All right, well, we've done a lot of work. You've done very well to get to this point now, and where do you think we're going next? Well, we're going to do slightly bigger looking fractions involving x and solving problems with those. So for the moment, take a rest, and I'll catch you in the next presentation, which is further equations with fractions. See you then.